Okay, crew, we're going to take a look at the type of problem that you make a comparison between one person's trip and another person's trip. We have two individuals. We have Sue, and if you look over here, we have Mike. So it says Sue takes a plane from Denver to Kansas City, and it's some known distance away. Mike drives a car from Salt Lake City to Kansas City, again, some known distance. They arrive at the same time in their location. If the plane travels 7 times faster than Mike's car and both individuals started their trip at the same time, how much longer, so that's implying a time there, how much longer does it take Mike to travel relative to Sue? Anytime you have a comparing trips problem, you should always start with this original idea that you're going to have V is equal to delta D over delta T. So both of these individuals are traveling at a constant velocity. I can write this equation out one time for Sue, and I can write it out another time for Mike. And so it's good to put the subscripts on here so that you can keep track of what's what. I'm just going to drop the delta, and I'm going to say ds over ts. And then for Mike, it's going to be Vm is equal to dm over tm. Okay. Now, the next step is to go through and start really truly figuring out what you know and what you don't know. I do know both of these individuals' distances that they are traveling. I do not, at this stage, know much about their velocity, so I'm just going to leave those for a second. Vs is equal to, now Sue went 991 km. And then there's her time down here, the time of Sue. Vm is equal to 1722 km over tm. So I still have a situation here where I have lots of different variables going on. I have a piece of information that's going to be very valuable to me, and it is this plane business being 7 times faster than the car. So Sue was in the plane, and so Vs is 7 times bigger. So Vs is equal to 7 times Vm. And I always like to go through and just pick a random number here and do a mental check. Does my mathematical statement make sense with the problem statement? If Vm were 100 km per hour, then I would multiply that by 7, and I would find that Vs, Sue's plane speed, is 700 km per hour. Okay, that is at least in line with what the problem is saying. Then this problem says, how much longer does it take Mike to travel relative to Sue? The interesting thing about this is wording like this usually implies that you are going to solve for a ratio. And so how much longer does it take Mike? This is going to be Tm divided by Ts. So what does that equal? That is what you're being asked to find. If I just gave a really brief little, let's say hypothetically the question mark equals 2, you would say Tm is twice as big as Ts. So that's the type of information I'm being asked for here. Okay, I have enough now that I can actually solve this problem. What I need to do is I need to get common variables between this thing and this thing. So I need to replace one of them here. And since this is already solved for Vs, I will just go ahead and replace that one. So this equation up here now becomes 7 times Vm is equal to 991, I'm going to drop the units for a moment, Ts. Over here, I now have Vm is equal to 1722 over Tm. Now I'm going to divide this 7 over into the denominator here, so it's going to be times 7 there. Okay, so that went away. And I'm going to set the two Vm's equal to each other. So I now have 991 divided by 7 times Ts is equal to 1722 divided by Tm. Now is when you should go and you should look at what we are trying to find. We're trying to find Tm divided by Ts. So this Tm that's down here needs to get multiplied up into the numerator on the other side, and I need to separate off all of these other numbers. So now it's going to look like this: Tm divided by Ts. So I've taken care of this thing going up here, and I've taken care of this thing. In separating out these numbers, I now have this 991 that's going to go into the denominator down here, 991. The 7 that's over here is going to go up into the numerator on the right hand side. So I have 7. Then I still have my 1722 number that was there from before. When I get my final number here, I have Tm over Ts is equal to, this comes out to be 12.1, and then I'll round that to an 8. That would actually be a unitless number. So this Tm right here would be in units of hours. Ts would be in units of hours, and those would be canceling, and so that is what I was being asked to find. It will take Mike exactly 12.18 times longer to travel. So this is just an example of one of these types of problems where you really don't have very many numbers. So you have to keep things symbolic, and you have to really sort out how you're going to arrange one variable in terms of another. Specifically, I'm referring to this step over here. Hopefully that made sense, and if it did, you should let your computer know.